Have you ever wondered what the future of lunar exploration holds? Imagine astronauts walking on the moon once again, but this time, it's not just a visit, it's the beginning of humanity's long-term presence on our closest neighbor. What if the moon could become a launch pad for missions to Mars? In 2025, we're about to witness some of the most exciting lunar missions ever. From international collaborations to groundbreaking technology, the moon is set to become the center of space exploration. Are you ready to explore what's coming next? Let's dive in. NASA's Artemis program. The excitement surrounding NASA's Artemis program is palpable as we edge closer to a new chapter in lunar exploration. The Artemis mission is not just a return to the moon, it's a stepping stone for humanity's journey to Mars and beyond. The Artemis II mission, scheduled for 2026, will be the first crewed flight around the moon since Apollo 17, marking an incredible milestone. 4 astronauts will embark on this historic journey, orbiting the moon before returning to Earth. Imagine the thrill of seeing our Earth from space once again, just like Apollo astronauts did decades ago. But what makes Artemis III, set for 2027, even more exciting is its ambition to land astronauts near the lunar South Pole. This is no ordinary landing site. The South Pole is a treasure trove, believed to contain vast amounts of water ice. This ice could potentially fuel future missions and even support a sustainable lunar presence. For the first time in history, we'll be walking on an uncharted part of the moon. NASA's ambitious plans go beyond just visiting. They're focused on building a sustainable lunar presence with habitats, scientific outposts, and resource mining, all key for preparing us to explore the Red Planet. The Artemis program is set to revolutionize not just lunar exploration, but the entire future of space travel. With technology, innovation, and international collaboration on its side, Artemis is paving the way for a new era of space exploration. Get ready to be part of history in the making. China's Chang'e missions. China's Chang'e missions are pushing the boundaries of lunar exploration, and 2025 promises even greater strides. The Chang'e 6 mission, launching in 2025, will make history by returning lunar samples from the moon's far side, an area that has never been explored by humans. This mission will touch down in the moon's South Pole Aitken Basin, one of the largest and most ancient impact craters in the solar system. Scientists believe this region holds answers to the moon's earliest history and secrets about the formation of the solar system. The Chang'e 6 mission represents more than just a scientific venture, it's a step toward China's ambition to lead in space exploration and lunar development. But that's just the beginning. By bringing back lunar samples from an untouched region, China will help scientists around the world unlock secrets about the moon's composition and the presence of water ice, which could be used for fuel and other resources in future missions. China's growing space presence will enhance international collaboration, especially as it partners with other nations to share data and findings. The Chang'e program is not only about exploration, it's also about sustainability. As China looks to build on its achievements and create a permanent presence on the lunar surface, Chang'e 6 is poised to deepen our understanding of the moon and reshape the future of lunar exploration for generations to come. India's Chandrayaan missions. India's space agency ISRO has been making remarkable strides in lunar exploration, and the next chapter of this journey is incredibly exciting. Following the success of Chandrayaan 2, which placed a rover near the moon's south pole, India is setting its sights even higher with Chandrayaan 4, set to launch by 2027. The success of Chandrayaan 3 in 2023, which landed near the South Pole, made India only the 4th country in history to achieve a soft landing on the moon. This achievement has not only positioned India as a rising space power, but has also opened up incredible scientific opportunities. Chandrayaan 4 will be even more ambitious, with plans to return lunar samples to Earth. These samples will help us understand the moon's geological history and its potential to support future lunar missions. But there's more. ISRO's focus on the moon's south pole is crucial because this region contains water ice, one of the most valuable resources for sustainable space exploration. India's lunar missions are poised to contribute vital data on the moon's resources and how they can be used for future space exploration. As part of an international lunar science community, India is playing a pivotal role in unlocking the moon's secrets. The Chandrayaan missions are paving the way for India to not only contribute to lunar science, but to become an essential player in the exploration of our solar system. India's lunar ambitions are just beginning, And the next mission is sure to push the boundaries of what we know about Earth's closest neighbor. Commercial lunar landers. The future of lunar exploration isn't just about governments, it's also about private companies stepping up to the challenge. In 2025, we're going to see more private sector involvement than ever before, with commercial lunar landers like Intuitive Machines and Astrobotic leading the charge. These companies are not just launching payloads into space, they are taking humanity a step closer to creating a permanent lunar presence. Intuitive Machines' IM-2 mission, set to launch early in 2025, will land near the Shackleton crater, a region that holds clues about the moon's water ice deposits. This mission will open doors to the exploration of lunar resources that could one day be used for fuel, water, and life support on the moon. Astrobotic's Griffin 1 mission, scheduled for late 2025, is another milestone in private lunar exploration. This mission will deliver scientific payloads to the moon, including experiments and technologies that could be vital for establishing a sustainable lunar infrastructure. The rise of commercial companies in lunar exploration signals a new era, one where private enterprise plays a major role in space exploration. These companies are helping to drive innovation, reduce costs, and make space more accessible. In fact, many experts predict that commercial lunar landers will not only change how we explore the moon, but will also play a critical role in future Mars missions. The partnerships between private companies and space agencies are forging a path toward a future where lunar exploration isn't just for a select few but is a global effort. The possibilities are limitless, and the moon is just the beginning. International collaborations. As the race to the moon accelerates, international collaborations are becoming a crucial part of the lunar exploration landscape. These partnerships are not just about sharing the costs of missions, but about combining the expertise, technology, and resources of multiple nations to achieve something greater than any one country could accomplish on its own. In 2025, we will witness some of the most exciting joint lunar missions, with countries like India, Japan, and even the United States teaming up for groundbreaking research and exploration. One such collaboration is the Joint Lunar Polar Exploration Mission, which India and Japan are developing. This mission will focus on the lunar South Pole, an area that holds vast reserves of water ice, one of the most valuable resources for sustaining human presence on the moon. By joining forces, these nations will combine their scientific and technological capabilities, ensuring that the mission is as successful as possible. The data collected will be vital for understanding the moon's resources and creating a sustainable future for lunar exploration. These international partnerships are more than just about scientific discovery. They're about building a united front for the future of space exploration. As nations collaborate on the moon, they are also laying the groundwork for future cooperation on Mars, asteroids, and beyond. The exchange of knowledge, technology, and expertise ensures that all countries involved benefit, while the collective achievement of humanity is pushed further into the cosmos. The moon has always been a symbol of human curiosity and ambition, but now it's also a symbol of collaboration. And as we work together to uncover its secrets, we also work toward building a future where space exploration is a global endeavor. Future lunar infrastructure. The vision for the moon is rapidly transforming from short-term missions to long-term infrastructure. The Lunar Gateway, a project initiated by NASA, is set to play a pivotal role in this transformation. This space station, positioned in lunar orbit, will serve as a staging point for crewed missions to the moon and beyond. The Gateway will provide astronauts with a safe and reliable location to dock, refuel, and resupply before heading to the moon's surface. This infrastructure is crucial for creating a sustainable human presence on the moon, and will be key in our efforts to explore Mars and other parts of the solar system. But the Gateway is only one part of the bigger picture. To support long-term lunar exploration, there's a need for advanced technology that can harness the moon's resources. NASA, along with other space agencies, is developing systems to extract water from the moon's ice deposits and use it for fuel, oxygen, and even drinking water. This technology is vital for sustaining astronauts on extended missions. Additionally, research into building habitats using lunar soil is underway, as this will allow for the creation of permanent lunar bases that can support future generations of astronauts. These efforts are laying the foundation for a self-sustaining lunar outpost that doesn't rely on Earth's resources. The goal is not just to visit the moon, but to build a lasting presence that can support human life and serve as a launchpad for further space exploration. With the right technology, international collaboration, and a focus on sustainability, the moon will become humanity's stepping stone to the stars. As we lay the groundwork for this future, we're not just expanding our reach into space, we're securing humanity's place as a multi-planetary species. So there you have it. 2025 is shaping up to be an incredible year for lunar exploration. With groundbreaking missions, international partnerships, and cutting-edge technology, the moon is closer than ever to becoming humanity's next frontier. What do you think the future holds for lunar missions? Let us know in the comments. Don't forget to like, share, and subscribe to Space Facts for more exciting updates on space exploration. The cosmos is full of wonders, and we're here to uncover them together. Until next time, keep looking up. What if I told you the universe is being pushed apart by something we can't see, touch, or fully understand? A mysterious force that makes up nearly 70% of everything, yet remains invisible. Yeah, I'm talking about dark energy, the biggest cosmic enigma out there. But what is it really? Why is it making the universe expand faster and faster, and what does that mean for the future of everything we know? Grab your curiosity, because today we're diving deep into a mystery that's literally shaping the fate of the universe. Are you ready to explore the unknown? What is dark energy? Have you ever felt like the more we learn about the universe, the less we actually know? Well, dark energy is the perfect example of that mystery. Scientists say it makes up nearly 68% of everything in the universe, yet we can't see it, touch it, or directly detect it. So, what is it, honestly? We don't fully know. But here's what we do know. Something out there is pushing galaxies apart, faster and faster. And that something is what we call dark energy. Imagine blowing up a balloon. You expect it to slowly stop expanding as the air fills it, right? But dark energy? It's like the balloon is speeding up the more you inflate it, defying expectations. That's exactly what the universe is doing. Instead of slowing down from the pull of gravity, it's accelerating outward. It's wild. Some think dark energy might be a property of space itself, like empty space still has energy. Others believe it could be a new kind of field or particle that we haven't discovered yet. Whatever it is, it acts like an anti-gravity force, stretching space over time. And the craziest part? It's everywhere. Right now, as you're watching this, space is expanding even in the vast emptiness between galaxies, and dark energy is driving that. So yeah, it's invisible, mysterious, and it's changing how we understand the very fabric of the cosmos. The more we search for answers, the more it pulls us into its mystery, just like it's pulling the universe farther and farther apart. Discovery of dark energy. Okay, let's rewind to the late 1990s, a time of chunky computers and questionable fashion choices. Astronomers were studying supernovae, those dramatic explosions that mark the death of massive stars. The plan was simple: measure how fast the universe was expanding and see how gravity was slowing it down. That's what they expected. But what they found? It flipped everything on its head. Instead of slowing down, the universe was actually speeding up. Imagine expecting to see a car decelerate after going up a hill, and instead it starts zooming faster, all on its own. That's how bizarre it was. Scientists were stunned. Something unknown was pushing the universe apart, and that something was quickly named dark energy. This wasn't just a tiny discovery, it was a cosmic bombshell. Two independent teams, both using different data, came to the same jaw-dropping conclusion. The expansion wasn't just continuing, it was accelerating. And suddenly, all those neat theories about a balanced universe, tossed out the window. In 2011, the Nobel Prize in Physics was awarded to the leaders of those teams. Why? Because they basically rewrote the rules of cosmology. This discovery didn't just suggest a new force, it demanded it. And that force is dark energy. Mysterious, unstoppable, and quietly shaping the entire universe while we're just here, trying to keep up. The role of the cosmological constant. You know what's wild? Einstein may have accidentally predicted dark energy more than 100 years ago. And then called it his biggest mistake. Yeah, really. He added a term to his equations called the cosmological constant, thinking it would keep the universe static because back then, everyone believed the universe wasn't expanding at all. But when Edwin Hubble showed that the universe was expanding, Einstein scrapped the idea thinking he'd been totally off. Turns out, he might have been onto something big. Fast forward to today, and scientists have brought the cosmological constant back from the grave. Why? Because it might just explain dark energy. Picture space itself having a kind of built-in energy, a quiet, invisible pressure that doesn't fade with time. That's what the cosmological constant represents. A steady, constant push that fills space and drives the universe to expand faster and faster. It's like a cosmic thermostat set on expand, always pushing outward no matter what. And it's not affected by matter, temperature, or time, just there, humming along in the background of reality. Some scientists think dark energy is this constant force Einstein once described. Others think it could be something dynamic, something that changes over time. But here's the big takeaway. Even when Einstein thought he was wrong, he may have glimpsed one of the universe's most powerful forces. The cosmological constant is now a leading contender in the race to explain the invisible hand stretching our universe apart. Crazy how science can loop back around like that, right? Dark energy versus dark matter. Let's clear something up because these two get mixed up a lot. Dark energy and dark matter are not the same thing, not even close. They may both sound like mysterious sci-fi terms, but they do completely opposite things. Imagine dark matter as the universe's glue, while dark energy is its great escape artist. Dark matter pulls things together. It's the invisible mass that helps galaxies form and stay intact. Without it, galaxies would fly apart because there wouldn't be enough gravity to hold the stars together. We can't see dark matter either, but we know it's there because of how it bends light and affects galaxies' movements. Think of it as the unseen hand keeping the cosmic dance from falling apart. Now, dark energy? That's the rebel. It doesn't pull, it pushes. It drives galaxies away from each other, accelerating the universe's expansion like a cosmic engine with no brakes. While dark matter works on local scales like within galaxies, dark energy works on the grandest scale imaginable, affecting the entire universe. Here's an analogy. If the universe were a cake baking in the oven, dark matter would be the flour holding everything together. Dark energy, that's the yeast, making the cake rise faster than expected. So yeah, dark matter is pulling the universe in, dark energy is blowing it apart. Two invisible forces, two cosmic mysteries, both completely changing how we understand space, time, and everything in between. The impact on the universe's fate. Alright, let's get deep for a second. If dark energy is real, and all signs say it is, it's not just tweaking the speed of our universe's expansion. It could be deciding the fate of everything that exists. I'm talking about galaxies, stars, planets, even atoms. Yeah, it's that big of a deal. So what happens if this dark energy keeps doing its thing forever? We might be looking at the big freeze. Sounds dramatic, right? But it's more like a slow fade. Galaxies will drift farther apart, stars will burn out, and over trillions of years the universe will become cold, dark, and silent. A frozen cosmos. Forever. But hold on, it gets even more bizarre. What if dark energy doesn't stay constant? Some theories say it might get stronger over time. If that happens, we're heading straight toward a terrifying idea called the Big Rip. Picture this. Galaxies tearing apart, then stars, then planets, then, eventually, you. Even atoms wouldn't survive. Everything gets shredded by expansion itself. It's like the universe hits the gas pedal and never lets go. Of course, there's also the opposite idea. What if dark energy weakens or even reverses? Then gravity might take over again and cause a big crunch, pulling everything back together into a dense point. The whole universe would collapse on itself, maybe even leading to a new Big Bang. No pressure, right? Just a mysterious, invisible force quietly deciding the ultimate ending of reality as we know it. The truth is, we're still in the dark. But one thing's clear, dark energy isn't just a background character, it's the main act in the story of the universe's destiny. Ongoing research and theories. Let's be real, dark energy sounds like something out of a sci-fi movie. But scientists around the world are working non-stop to figure out what it actually is. And they're getting creative about it. Like, seriously, next-level creative. One of the biggest efforts is the Dark Energy Spectroscopic Instrument, or DESI. It's mapping the positions of millions of galaxies to see how the universe has expanded over time. Think of it like taking a cosmic time-lapse. The more we learn about how galaxies moved in the past, the more we can understand what dark energy has been doing. But DESI isn't alone. The Euclid mission by the European Space Agency and NASA's Nancy Grace Roman telescope are also joining the hunt. They're aiming their eyes deep into space to catch clues about this invisible force. Scientists are hoping to figure out whether dark energy is constant, like Einstein's cosmological constant, or if it changes over time like a rolling wave. And then there are the mind-bending theories. Some physicists think dark energy might be connected to quantum fields. Others believe it could point to a hidden dimension or even support string theory. Yeah, the one that talks about tiny vibrating strings making up the universe. Here's the bottom line: dark energy is the biggest unsolved mystery in modern cosmology. We don't know what it is, we don't know how it works, but we know it's real. And it's rewriting everything we thought we knew about the universe. The more we search, the stranger it gets. And honestly, that's what makes it so thrilling. And that's the strange, fascinating world of dark energy. An invisible force that might just decide how the universe ends. Crazy, right? The more we learn, the more questions we uncover. If you found this mind-blowing or even slightly unsettling, you're not alone. Space is full of mysteries, and we're just getting started. So, if you love exploring the unknown, don't forget to subscribe to Space Facts for more deep dives into the cosmos. Until next time, keep looking up, because the universe has way more secrets waiting to be discovered. In 1610, Galileo saw Saturn, but he didn't understand it. His telescope showed strange ears, not knowing they were icy rings that would puzzle humanity for centuries. Today we know those rings are vast, delicate, and possibly vanishing before our eyes, a cosmic masterpiece, fading in silence. Scientists think a lost moon or a celestial collision may have created them. But we still ask, why Saturn? Why not the others? If you stood beneath those radiant bands, would you feel awe or sorrow for what's slipping away? Let's explore the truth behind Saturn's vanishing crown. The enigmatic beauty of Saturn's rings. If you were standing on the surface of one of Saturn's moons, you'd see something that almost doesn't look real. Towering arcs of shimmering ice stretching across the sky like a celestial ribbon. For centuries, this sight has mystified stargazers and astronomers alike. Saturn's rings aren't just decoration, they're clues. Clues to a violent cosmic past, to the invisible forces that shape our universe, and to the kind of beauty that only space can sculpt. But what's wild is that when Galileo Galilei first saw them in 1610, he had no idea what he was looking at. His telescope was primitive, and to him, Saturn looked like it had ears. It wasn't until decades later that scientists realized these weren't ears or wings, but rings. Massive, flat rings made of something far more fragile than rock, ice. Not one single ring, but thousands of tightly packed ringlets spanning hundreds of thousands of kilometers. They're wide enough to stretch nearly the distance from Earth to the Moon, but they're razor thin, barely 10 to 30 meters thick in most places. So, why do they exist at all? Why Saturn and not Jupiter or Uranus in the same way? That's where things get fascinating. Let's break it down. What Saturn's rings are really made of. Most people think Saturn's rings are solid, like a giant hula hoop floating in space, but that couldn't be further from the truth. These rings are made of billions, yes, billions of tiny particles, each orbiting Saturn independently. They range from microscopic dust grains to house-sized boulders, and they're mostly composed of water ice, which explains why they reflect sunlight so brilliantly. But here's the twist: they aren't pure ice. Hidden among the icy debris are specks of rocky material and organic compounds. That's right, some of the same carbon-rich molecules that may have played a role in forming life on Earth are found in Saturn's rings. Scientists think the difference in ring color, some being brighter, others darker, might be due to the varying amounts of this dusty contamination. And while they look smooth from afar, the rings are more like a cosmic traffic jam up close. These particles constantly collide, clump together, and break apart again. It's chaos, but organized chaos ruled by gravity. Every motion, every gap between rings is shaped by Saturn's moons tugging on the particles like invisible hands sculpting art. And that chaos may hold the key to how the rings even got there in the first place. How did Saturn's rings actually form? A moon torn apart. That's one of the most widely accepted theories behind the formation of Saturn's rings. Sounds brutal, right? And it was. Scientists believe that long ago, Saturn may have had a large icy moon that drifted too close, within the planet's Roche limit, a point where Saturn's tidal forces became stronger than the moon's own gravity. The result? The moon was literally shredded into pieces. But that's just one version of the story. Another theory is even more chaotic. What if two moons collided at high speed, turning into a spray of debris that spread around Saturn like a slow-motion explosion in space? Over time, gravity helped those icy fragments settle into the thin, structured rings we see today. This theory is supported by how flat and disc-like the rings are, just like the aftermath of a spinning cosmic smash-up. Some scientists even think these rings could be the remnants of material that never formed into a moon at all, a frozen ghost moon that failed to become whole billions of years ago. But here's the catch. No matter the theory, one thing remains clear. The rings are a result of destruction. Something had to break, rip, or explode for them to exist. Saturn's beauty is born out of cosmic violence, and that makes it even more incredible. Are Saturn's rings old or surprisingly young? You might assume Saturn's rings have been around forever. After all, the planet itself is over 4.5 billion years old. But what if I told you that the rings might be younger than the dinosaurs? That's right. Some scientists now believe that Saturn's rings may have formed as recently as 100 million years ago, when T-Rex roamed Earth. That's practically yesterday on a cosmic timeline. How could something so massive be so young? It all comes down to their brightness. The rings are incredibly reflective, meaning they haven't been exposed to space dust and debris long enough to darken over billions of years. On the flip side, there's a competing theory that says we've just gotten lucky. Maybe the rings really are ancient, but their icy particles constantly recycle themselves, colliding, breaking down and reforming, keeping them looking fresh and clean despite their age. Cassini's mission tried to settle the debate, measuring how much ring material is falling into Saturn's atmosphere. The data leaned toward a shorter lifespan, meaning we may be living in a rare moment in time when Saturn is dressed in her finest. Either way, the rings are temporary. Whether they're ancient or newborn, they won't last forever. We're witnessing a fleeting masterpiece, and most of the universe won't even get the chance. What NASA's Cassini mission uncovered about the rings. One spacecraft got closer to Saturn's rings than anything in human history, and it changed everything. NASA's Cassini mission, launched in 1997, didn't just orbit Saturn, it danced through its rings, it flew between them, and what it saw was astonishing. Cassini revealed that the rings aren't uniform at all. They're full of waves, literal ripples caused by gravitational tugs from Saturn's dozens of moons. These waves aren't just beautiful, they act like seismic maps. They help scientists understand Saturn's interior structure, the same way earthquakes help us understand Earth's core. Wild, right? And then there were the propellers, tiny gaps carved by moonlets no bigger than a city block. These baby moons move like little shepherds, pulling and pushing ring particles, leaving trails behind like ships through ice. It's a whole ecosystem of motion. Collisions, orbits, spirals, all governed by gravitational forces we can't see but Cassini could feel. What stunned scientists most was the sheer level of detail. They found sharp edges, sudden gaps, and braided structures like strands of hair woven by the cosmos itself. Saturn's rings aren't just pretty, they're alive with motion. Cassini didn't just observe them, it revealed a complex, dynamic system still evolving before our eyes. Will Saturn's rings eventually disappear? They look eternal, but Saturn's rings are fading. Right now, as you read this, those magnificent ice particles are falling, bit by bit, into the planet they orbit. It's called ring rain, and it's caused by Saturn's magnetic field, pulling charged particles from the rings down into its atmosphere. NASA estimates that each second, tons of ring material is being lost forever. Think about that, a structure hundreds of thousands of kilometers wide, vanishing grain by grain like sand in an hourglass. Scientists now believe the rings could be gone in as little as 100 to 300 million years. In cosmic time, that's a blink. And that means we are alive at one of the rare moments in history when Saturn even has rings this bright and massive. Most other planets don't get this kind of spotlight, we just happen to be born at the perfect time to see it. The rings are like fireworks on a galactic scale, stunning, fleeting, and impossible to ignore. One day future civilizations may only see Saturn as a plain gas giant. No icy crown, no shimmering halo, just a memory left in textbooks and telescopes. And that makes every glance at Saturn now feel a little more sacred. The role of Saturn's moons in shaping the rings. Saturn's moons play an incredibly crucial role in the creation, maintenance, and structure of its rings. These moons act as both sculptors and guardians of the rings, exerting gravitational forces that shape the particles within them. Saturn has over 80 moons, but many of them are especially important for the delicate dance of the planet's rings. Some moons, like Pan and Atlas, are small yet vital to the structure of Saturn's rings. They create gaps, or propellers, within the ring material, where the gravitational pull of the moon pushes particles into a tightly packed structure while leaving a gap in its wake. These gaps resemble the paths left behind by ships moving through ice, and they help maintain the ring's shape and distribution. The effect is not just visual, but also vital for the dynamic behavior of the ring system. On the other hand, moons like Mimas, Enceladus, and Dione have more indirect roles. They interact with the rings by generating gravitational waves, small fluctuations that ripple through the material, organizing it into neat, concentric bands. These waves influence the ring particles' movement and maintain their organized chaos. Through their gravitational interactions, Saturn's moons help to prevent the particles from scattering away into space, ensuring the rings stay intact over millions of years. Interestingly, the material in Saturn's rings is not static, it's in constant motion, constantly being tugged by the moons. This interaction is a prime example of how moons and rings coexist in a delicate balance, with each influencing the other. Without these moons, the rings would likely lack the fine structure and order they currently display. Rather than a simple floating collection of ice, Saturn's rings are a complex, gravitationally controlled system that relies heavily on the nearby moons to sustain its beauty and form. Thanks for joining me on this incredible journey through Saturn's mysterious rings. From icy debris to shattered moons, the secrets they hold are as vast as space itself. There's still so much we don't know, and that's what makes it thrilling. Every new discovery brings us one step closer to understanding the universe we call home. So, what do you think created Saturn's rings? Drop your thoughts in the comments below. Let's start a cosmic conversation. And if you love discovering the secret of the universe, don't forget to subscribe to Space Facts and hit the bell icon for more adventures. NASA's recent discoveries deep within the sun's core are rewriting our understanding of the star that sustains life on Earth. Using cutting-edge missions like the Parker Solar Probe and the Solar Dynamics Observatory, scientists have unveiled astonishing phenomena, from massive magnetic tornadoes to mysterious plasma tsunamis, that reveal the sun's inner workings are far more dynamic and dangerous than ever imagined. One powerful fact stands out: the sun loses 4 million tons of mass every second, a relentless countdown to its eventual demise. The sun's secret nuclear furnace. NASA's latest data has revealed surprising new insights about the sun's core, challenging long-held beliefs. Traditionally, scientists thought the sun's energy output was stable, fueled by steady hydrogen fusion. However, recent findings suggest the core behaves unpredictably, exhibiting what researchers are calling fusion bursts. These bursts are violent, explosive events deep within the sun's 27 million degree center, unlike the familiar solar flares that occur on its surface. These fusion bursts are powerful enough to challenge existing physics models. Remarkably, the sun seems to hide these internal explosions by bending light, making them invisible to direct observation. If one of these bursts were to break free from the core's containment, it could have catastrophic effects on Earth, potentially collapsing our planet's magnetic field within 12 hours. This magnetic shield protects us from harmful solar and cosmic radiation, so its loss would be devastating. NASA warns that this behavior is abnormal for a star of the sun's age and stability, suggesting the sun might be undergoing unexpected internal changes. While this doesn't mean immediate danger, it raises important questions about our star's future and the need for continued monitoring. The solar vortex that defies physics. NASA's Solar Dynamics Observatory has observed massive swirling waves and vortices on the sun, including large-scale motions beneath its surface, but there is no verified evidence of a 300,000-mile-wide whirlpool inside the sun's core, spinning backward or causing time dilation effects. Research indicates the sun likely has polar vortices, rings of swirling magnetic patterns near its poles that evolve with the solar cycle and affect magnetic field reversals. These vortices form around 55 degrees latitude and migrate poleward, disappearing during solar maximum when the sun's magnetic polarity flips. However, these are surface and near-surface phenomena, not deep core vortices. The claim that such a vortex breaks fluid dynamics laws, causes time to slow, or threatens to tear the sun apart within a billion years, is not supported by current scientific data or NASA releases. The sun's core fusion processes and magnetic dynamics are complex, but remain consistent with established physics models. NASA has not publicly released or deleted data supporting such extreme assertions. The concept of a magnetic time warp or core vortex growing to catastrophic size appears speculative and unsupported by peer-reviewed research or official NASA findings. The sun's hidden black hole heart. There is no credible scientific evidence or NASA data supporting the existence of a microscopic black hole inside the sun's core. The idea that such a black hole, with the mass of a small moon but atomic size, lurks within the sun, contradicts established physics. According to current understanding, any microscopic black hole formed during the sun's birth would have evaporated long ago due to Hawking radiation. Gravitational anomalies and unexplained vibrations in the sun are actively studied, but they are generally attributed to complex plasma dynamics, magnetic fields, and fusion processes, rather than exotic objects like black holes. The sun's core is governed by nuclear fusion, which provides a stable energy output and prevents catastrophic collapse. The scenario of a black hole inside the sun triggering a hypernova is inconsistent with stellar evolution models. Our sun, a middle-aged star, is not massive enough to end its life as a hypernova. Instead, it will eventually become a red giant and then a white dwarf over billions of years. While the sun's core holds many mysteries, the black hole hypothesis remains speculative and unsupported by scientific evidence or NASA's observations. Ghost star inside our sun. So, there is no scientific evidence or NASA helioseismic data confirming that the sun consumed a twin star billions of years ago. The sun actually formed about 4.6 billion years ago from a collapsing cloud of gas and dust. And, well, while binary star systems are pretty common, our sun is understood to have formed as a single star. Helioseismology, which studies solar oscillations, hasn't revealed any chemical imbalances or elements that would indicate a consumed star inside the sun's core. The idea of a second magnetic field caused by the remnants of a twin star orbiting within the sun just isn't supported by current solar physics. The sun's magnetic activity and solar cycles are explained by the solar dynamo, a complex interaction of plasma flows and magnetic fields within the sun's convective zone. Variability in solar storms arises naturally from these processes without needing a trapped star, and the concept of a vampire star draining energy from planets is really speculative and not applicable to our sun's characteristics. While the sun's history and future definitely hold mysteries, the notion of it having devoured a twin star remains a hypothesis without observational backing or theoretical support. The sun's quantum abomination. So here's the thing. There's just no verified scientific evidence or NASA data backing up the claim that particles move faster than light near the sun's core, or that physics somehow breaks down in a 200-mile-wide zone there. According to established physics, nothing can travel faster than light in a vacuum. And causality, meaning cause comes before effect, is a fundamental principle upheld by Einstein's theory of relativity. Neutrinos produced in the sun's core do travel close to light speed, but they don't actually exceed it. The idea of time loops, miniature wormholes, or quantum anomalies causing gravitational ripples and atomic clocks skipping time all over the globe just doesn't have any observational or experimental support. And, honestly, no recorded event in 2012 or any other year has shown atomic clocks worldwide skipping 0.7 seconds simultaneously because of solar activity. While the sun's core is definitely extreme and complex, our current understanding still lines up with relativity and quantum mechanics. The sun does influence the solar system through gravity and electromagnetic radiation, but it's not testing or rewriting the fabric of reality. At the end of the day, these claims are pretty speculative and just aren't grounded in mainstream astrophysics or NASA findings. The sun's corpse-like core. When it comes to the idea of a corpse-like core, there's just no credible scientific evidence or NASA helioseismology data showing a 2,000-mile-wide dead zone in the sun's core where nuclear fusion has stopped. The sun's core is actually continuously sustaining nuclear fusion, converting hydrogen into helium, and producing the energy that powers the sun and supports life here on Earth. Helioseismology, which is the study of solar oscillations, has not detected any region where fusion has ceased. Solar wind variations that have been observed since the 2000s are actually due to changes in the sun's magnetic activity and solar cycle dynamics, not because of a failing core or some kind of emergency backup power. The idea of a growing cold dead zone feeding on the core and mimicking fusion through electrical currents is, honestly, speculative and not supported by current astrophysical models. Sure, stars do change as they age, but the sun is stable and expected to keep its fusion processes going for billions of years. The whole concept of cancerous cold spots consuming a star from the inside just isn't recognized in stellar physics. While it's super important to keep monitoring the sun's behavior, claims about a dead core and imminent collapse within centuries really don't have a scientific basis and actually contradict what we know. The sun's doomsday protocol. Let's talk about the so-called doomsday protocol. There's absolutely no scientific evidence or NASA data supporting the existence of a kill switch called terminus inside the sun, or any star for that matter. The idea of a dormant magnetic weapon buried 150,000 miles beneath the sun's surface that could fire a relativistic plasma jet to sterilize solar systems is, well, purely speculative and just not grounded in astrophysical research. NASA's Parker Solar Probe is out there studying the sun's magnetic fields and solar wind, but it hasn't detected any signals that would suggest a self-destruct mechanism or countdown linked to ancient supernovae. The sun's activity cycles and magnetic behavior are explained by well-understood processes like the solar dynamo and magnetic field reversals. There's no need to bring in neural network-like filaments or cosmic railguns. The whole idea that stars have built-in self-destruct systems causing civilizations to go silent is really more science fiction than astrophysical fact. The sun's life cycle is governed by nuclear fusion and gravitational equilibrium, and honestly, it's expected to remain stable for billions of years before eventually evolving into a red giant, and then a white dwarf. So, in summary, the terminus kill switch narrative just doesn't have any basis in current solar physics or NASA findings. Thanks so much for exploring the sun's deepest secrets with Space Facts. If you found this journey into our star's core as mind-blowing as we did, don't forget to hit that bell icon so you never miss a cosmic update. Subscribe now to join our community of space enthusiasts, and drop a comment below. What discovery shocked you the most? Your thoughts really do fuel our mission to bring the universe closer to you. Stay curious and keep looking up.